Okay, so we're going to look at some math and finance problems, and in particular, we're going to calculate the future value for two different scenarios using the future value formula in Excel. Now, there are formulas, regular math formulas for these calculations, but we're going to do everything in Excel, so we don't need those formulas. So our first example, suppose that you set aside $5,000 into an account and collect interest on the account at 5% APR compounded monthly. What is the amount in the account after 6 years? And then after that, we'll calculate how much interest that you earned on that account. So what I've done is I've set up a table here to calculate our values for us, to hold our numbers that we can then put into our formula using our cell references. So the present value we're given is $5,000. The rate that we're given is 5%. Now we're compounding monthly, so compounding 12 times per year. So depending on the problem, of course, you might need a different value here. If this was quarterly, it would be 4. If it was annually, it would be 1, and so forth. But monthly is very common. The number of years, we want to know how much we have after 6 years. And then we want to calculate our future value. Now, if you've never used the future value before, you can go ahead and search for it using our insert function and then looking for future value. And the future value function we want is FV. And so if we click enter, we get this nice pop-up window that tells us what all the components of our formula need to be. Now, the rate is not the annual rate, it's the rate per period. So notice that it gives you a little note here. 6% annual. For quarterly payments, you have to divide by 4. So our rate is the 5% rate divided by the number of times we're compounding. So 5% over 12. The N per is the total number of payments. So that would be the number of compounding periods times the number of years. Now, in this particular example, we don't have a payment, so we're going to skip that. We do have a present value. Now, in these formulas, you either use the payment or the present value. Typically, you generally don't use both of them. And then we can ignore the type because we're going to go with the default. And then we hit OK. Now, when we do these formulas, typically Excel is an accounting program. And so you'll typically get, if you put in a positive present value, you'll get a negative future value. You can fix that by adding a minus sign in front of your present value in the formula, and then it will calculate. It's the same value, but now you'll get a positive outcome. Now, if I want to calculate the amount of interest earned, since I haven't been making any payments, basically the interest earned is just the difference between the future value and the present value. And so in this case, I will have $6,745.09 in the account, which means that I will have earned $1,745.09 in interest. Now, the second example we're going to do is going to use the payment option instead of the present value option. So suppose that you are saving up for your child's future college fund. You make payments of $125 per month into an account, earning 4% interest compounded monthly. How much money is in the account after 18 years? How much money will you have essentially to spend on your kid's college fund? How much interest did you earn? So again, I've set up a table to keep track of our different components. So we have $125 payment. Our interest rate is 4%. We're paying in monthly, and this is compounded monthly. These have to be the same, both the payments and the compounding periods. We are paying in for 18 years. And so our future value, so again, we're going to use our future value function. Future value. And again, the rate is the rate per period. So this is going to be 4% divided by the compounding. The number of payments, N per, is the total number. So it's compounding times years. And now we're going to use the payment instead of the present value. That's the 125 in this case. And again, you can see right here, it's giving us this negative value. So I'm going to put a negative sign in front of my payment amount so that my output of my formula is a positive value, because mathematically that's what we expect, because we're not accountants. And then we don't need to worry about the present value and the type. We can accept 0 and the default. And so what we found is that the future value of our account is $39,449.06. And the amount paid in is going to be, this is something we have to calculate if we want to figure out how much interest we've earned, how much of our own money did we put in? Well, that's going to be the amount of the payments times the number of payments that we've made. And so then the interest earned is the difference between the amount we have in the account minus the amount that we've paid in. And so what we've paid in is $27,000 over these 18 years, but that's earned us $12,449.06 in interest.